We're currently near Florence, Alabama, or Tuscumbia, Alabama, at a place called the Seven Springs Lodge and Rattlesnake Saloon. It is a privately owned restaurant slash lodging place that you can come and you can stay. They have hiking trails. You can pay a day use fee. It is a wonderful place to come check out geology. They have miles of trails. Most of the exposures are of the Hartselle Sandstone. In this case, they're up to 30 plus feet high. There's really good exposures of some soft sediment deformation features, cross beds, and you can see this really meaningful influx of sediment during the Mississippian. The original interpretation of this clastic unit is it is the influx of sediment from the Ouachita-Appalachians. Stratigraphically, the other carboniferous rocks below are all carbonates or cherts. And so once you get to the Hartselle, that's the influx of that clastic sediment. If you're at this location or were to travel towards Birmingham following the Hartselle, you would find that's the thickest accumulation of Hartselle, and it thins as you go towards the northwest in the basin. Once you hit Birmingham, that trend kind of turns towards the northeast, and you'll still see a somewhat thick accumulation of Hartselle as you head towards our other stops, but this is one of the best exposures. Fossil logs are also present in that thickest portion of the trend. The interpretation that all that sediment was coming from an early uplift like the Ouachitas or southern Appalachians is based on logs and the thickness trends, isopachs, from both outcrop data and well logs and cores. And that was an interpretation for a really long time. Some other interpretations have come in, perhaps that you're bringing that sediment in from the north. Uranium-lead detrital zircon has been tried to use to look at those different routing options for the sediment into the Black Warrior to account for the Hartselle Sandstone. The first studies interpreted a number of things, but they found Grenville grains, which are not super distinctive because Grenville grains are everywhere. They also found mid-continent grains, which those are 1.5 billion years old. Those are about as distinctive as the Grenville grains. They're really old. There's been a billion plus years of recycling, but those early studies interpreted that to reflect a mid-continental drainage. Didn't really account for any sort of recycling. There are also about 400 to 410 Ma grains present in the Hartselle. Those zircon grains were interpreted to come from the northern Appalachians, which is the closest present-day source for those 410 Ma grains from bedrock. You don't necessarily see those populations in any intercontinental basins. And if you want that comparison, there'll be a new paper out, Jackson et al. 2026. It'll be in a new GSA memoir. And it found that the Hartselle is not significantly like those intracontinental sandstones that would be the correlatives. So a mid-continental drainage, it really isn't reflected in the rock record when you look at the detrital zircon in high detail. McKay et al. 2021 proposed that those could be locally sourced, and we're going to explore that a little more on this trip, but testing the original idea from the Bill Thomas kind of 1970s, 1980s model for how you route sediment into the Black Warrior Basin, we proposed that we could account for all the zircon locally. That would make the outcrop interpretations from the 70s and 80s all very valid. It would make perfect sense to have a much more isolated drainage basin. It wouldn't require these big intracontinental drainages that we just can't account for. Other data they used to try to justify this large drainage system just didn't really make sense too. They found metamorphic grains, sillimanite, that they thought, well, you can't have sillimanite locally sourced, so they has to come from somewhere else. But that's not true at all. In fact, there's a Geological Survey of Alabama publication called Sillimanite in Alabama. So there is sillimanite locally present. There are metamorphic rocks locally present that could account for the metamorphic grains observed in the Hartselle that has been tried to use as justification for these big drainage basins. But when you look at the actual geology, maybe some of that data doesn't necessarily exist or need to have these really complex solutions. I should also note, as the Hartselle is being deposited in the Mississippian, that would be when a lot of those metamorphic rocks that contain things like sillimanite are undergoing peak metamorphism. So there is tectonism in the area at the time of Hartselle deposition. The reference, if you need that for any sort of metamorphism or timing of deformation, Stowell et al., 2019 and 2021. 2021 is a field guide, but they both have information. But both of those references have age controls for metamorphism in the Alabama Blue Ridge, which is really important information for this big story.